Good morning, students. Welcome to today's online class. Today we are going to see about Fortinet Network Security Expert 4 certification, some question review. So, first, let me tell you about Network Lab. That is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at Network Lab is to provide our clients with exceptional exam preparation experience for certification in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today we are going to discuss some topics like operation modes, security policies and protection, logs, troubleshooting, and network interface in FortiGates. So let's begin. First, we are going to talk about operational modes. Which two statements are true when FortiGate is in transparent mode? So we have to choose two options. And let's see, there we got a picture that can help us. And the first one says, by default, all interfaces are part of the same broadcast domain. That option for me is true because when you use the FortiGate in transparent mode, you have all the interface in the same broadcast domain, like the same VLAN. This mode put the FortiGate like a switch, for example. So if you have, for example, a FortiGate with, I don't know, 5 ports, and this FortiGate is in transparent mode, all these ports are part of the same broadcast domain. As a switch at the beginning when you have the VLAN 1, because that is the default configuration. So, see, for me this option is true. The next one is the system network IP schema must be changed when installing a transparent mode. No, you don't have to change anything on your network design about IP address or something like that when you are installing a FortiGate in transparent mode. So that option for me is not correct, it's wrong. The third one, the C, static routes are required to allow the traffic to the next hub. No, that is wrong. The only route that you need in the FortiGate in transparent mode is for the admin. Then the FortiGate only is a transit firewall that receives and sends the traffic depending the policies that you have on that FortiGate, but you don't have to configure anything about routing. That is, as his mode says, is transparent. So this is wrong. And the next one says that FortiGates forward frames without changing the MAC address. That is true because, as I told you, this FortiGate is in transparent mode and it doesn't change anything that goes through the FortiGate. And let's see some official documentation to confirm that concept. As you can see there, this is the Fortinet community, and you can see that in transparent operation mode, FortiGate forward frames without changing the MAC address. When the client receives a packet from a server connected to a different FortiGate, the frame contains several real MAC address. FortiGate does not change the MAC address header. FortiGate is a layer 2 bridge or switch, as I told you on the others option. So our answers are option A and option D. Great. Let's continue. Let's see. Next, we have security policies and protection, which two statements describe how the RPF check is used. We need to choose two answers. And there we got the first one. Well, let me tell you first what is RPF. That is a mechanism that the FortiGate use to prevent the IP spoofing. For example, let me show you this picture there. There, if you have the user A is going to communicate through this FortiGate, and this FortiGate checks if he knows how to give an answer through this interface. If he has an out on his routing table for this interface. That is the reason why if you make some traffic from this computer to, for example, computer and user C, from this one, this is going to work. But if you make the same for this interface, this is not going to work because the FortiGate doesn't know how to reply back this communication. For example, if you receive traffic from this computer to the FortiGate, there you won't know how to respond. And for this option, if you make a traffic from this computer to this FortiGate, and for example, is not expecting this traffic to from this interface, the RPF have to block this communication. So let's see the options. The RPF check is a mechanism that protects the FortiGate and the network from IP spoofing attack. For me, that is the correct option. Let's see the others. Is run on the first send and reply packet of any new session. No, because this is used on the reply packet of the session. The next is run on the send packet of any new session. No, that is wrong, as I told you. And the next, the D, run on the first reply packet of any session. Yes, because when you make a communication from one computer and you may, for example, from user C, you make the reply, this device is expecting your reply, and that will work. If this FortiGate doesn't expect that reply is going to block the traffic and use the protection. So that is why, for me, option A and option D are the correct options. And as you can see, we work on it. So next, the next one is about logs. Which of the following statements about backing up logs from the CLI and the downloading logs from the guide are true? We have to choose two. The option A is download the lockdown logs from the GUI are limited to the current filter view. I'm going to show you in a lab how this works. Let's see the other options. Log backups from the client cannot be restored to another FortiGate. Log backups from the CLI can be configured to load to FTP as a scheduled time. And the log download from the GUI are stored as NSE4 compressed files. So let's see this option in a lab. What we want to see is if we put a filter. Let's see, we have one filter there, and we have another filter on the destination. Let's see, we have some logs there. Let me see how we download this information. As you can see, this traffic is on this format. That log. Let's open this file, and as you can see, let me put a file. As you can see on the source IP address, I only have the 10.88.2.21. If I take a look on the other logs, there is another one. And if I take a look, for example, in another one, there is the same IP address. And for the destination, we want to see the same. We want to see 192, 168, 254. And as you can see, we have the same IP address on all the logs. So that confirms our theory about the filters. And this one confirms the theory about the logs format. Let's see, if we go to log settings, we don't have any option there or any part of the FortiGate that let us upload logs from another FortiGate. So if we take a look again on the options that we have, the option A is correct. Download from the GUI are limited to the current view filter. And the option B, the logs cannot be restored to another FortiGate, are true. This one, you can schedule the logs to load as a scheduled time. And the compressed files are not downloaded in NSE4 compressed file. So let's continue. Let's see what we have. Our answers are option A and option B, as we saw in the lab. Next, we got a troubleshooting, and there we got a picture where we have a web client, a FortiGate, and web server. Let's see, in the network shown in the exhibit, the web client cannot connect to the HTTP web server. The administrator runs the FortiGate built-in sniffer and gets the output shown in the exhibit. What should the administrator do next to troubleshoot the problem? Execute another sniffer on the FortiGate, this time with that IP address, execute a debug flow, capture the traffic using external sniffer connected to port 1, or run a sniffer on the web server. As we can see there, we got a sniffer that is showing how is the traffic from in the port 80 and in any interface. So that only works to see if we have a communication between any IP address or devices. So if, let's see, the first one says execute another sniffer on FortiGate, this time with another filter. No, because we are going to watch the same thing that we are watching there, and that won't help us to solve the problem. The option B says execute a debug flow. For me, that option is valid because if you execute a debug flow when you are in the FortiGate, you can see how the packets are working. For example, if we take a look there, and let me see, I was using some command there, but I don't have, let me see. And we generate some traffic. We can see in this FortiGate, let me stop this. That is a lot of information. And the reason is because we are making a lot of traffic. And if you see, and if you take a look, let me see any example there. Well, you can see a communication there. As we can see, we have a communication from the IP address that is with the IP 1.2 and to internet. And we can see that we received the packet there, and it was allowed by the policy 1 in the last line. So that is what we want to see to make a troubleshooting. Okay, it is stopped. On this line, we can see that the traffic was allowed, and that is the kind of logs that we want to see to solve a problem. So for me, this option is valid. As we can see, the next is capture the traffic using an external sniffer connected to port 1. This one could be valid, but will be the same, honestly. These two will be the same because if you use a sniffer or you capture a traffic, you only will see how is the communication, and if you are missing some kind of packet, but you are not going to see if the FortiGate is blocking something or any policy is allowing letting pass the traffic. So our best option was the option B, execute a debug flow. Next, we got a network interface, and there it says an administrator need to increase the network bandwidth and provide redundancy. What interface type must the administrator select to bind multiple FortiGate interface? So the first one, VLAN interface. The VLANs are a logic interface, and if you make, for example, 20 VLANs or 2 or 3, you are not going to have more bandwidth. So that is a wrong option. And if you see a software switch interface, that is a logic interface, a virtual interface that is not going to add traffic with a physical interface. This one, aggregate interface, is a way to increase the network bandwidth and provide a redundancy by configure multiple interface. And for example, we can say that we have the interface 1 and the interface 2 connected to another FortiGate. We can use aggregate interface to group this interface, and for example, if I have in one 1 gigabit and the other one 1 gigabit, we can say that we can have a redundancy and provide a better network bandwidth, because if you apply aggregate interface, the traffic is going through both, and in the FortiGate you are going, or the device, you are going to see this interface as one. Physically you could have two interfaces, but you are going to see logically as one. So for me that is true. And the next one, redundant interface, for me that is not true, because when you have redundant interface, the traffic is only through one interface, and when this interface fails, goes to the other interface. So that doesn't add bandwidth. And let's see, as we can see there, the option was the C, the correct answer. So thank you all for attending today's class at 591 Lab, and we hope you found the material informative and helpful. Remember, practice is critical to mastering any new skill, so review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day.